Hello, thank you for joining us. Today we'll be giving an ethical analysis of the Washington Post data collections and visualizations on US police shooting data. So let's set the stage of the podcast by bringing up a project that we worked on for our CS 5010 course this summer, where we investigated bias and fatal police shootings in the United States. First, we had to choose a data set, and we chose the Washington Post data because it is updated regularly and is more comprehensive than the data provided by the FBI and CDC. The data contained 5,489 records and counted shootings of civilians in the US by police officers that resulted in deaths since the beginning of 2015. Overall, our main goal was to communicate the prevalence of police shootings within the United States using data visualizations. We hope to gain insight on a few questions and created visualizations that answered them. For example, some of the questions we sought to answer in our project were, what are the demographics of police shooting victims in the US and how have these demographics changed over time? Also, what are the circumstances surrounded by police shooting incidents? In addition to what extent are inequalities in police shooting victims' demographics attributable to different location and circumstances? In addition to what cities and states are police shootings more prevalent? So, given this problem in our ethical analysis, we realized that our stakeholders were included people that were affected most by our data collection methods and also our visualizations. So first, advocacy groups who would be interested in our analysis to communicate inequalities backed by data, police departments who would want to use our data to improve police trainings, government legislators who would use our data to inform their decision on allocating resources and policy, and in turn, everyone in the United States being affected as a result of policy changes and any other changes that may result from our analysis, in addition to media outlets who would inform the public on news and information regarding our analysis as well. So the two major dilemmas we faced during this project, which we'll go into more detail later, is one, how should we as data scientists use crowdsourced data? And two, how can we reduce the spread of misinformation through visualizations? So the Washington Post data was largely crowdsourced, which is why it had more observations than the FBI. And with crowdsourced data, you could gather more data at a quicker speed. And also it leads to increase in data diversity. But it's important to look at the relational view of the data. So Leonelli and Tempini write in their book, Data Journeys, without the ability to track data, without the ability to track how data change themselves and their environment as they move across contexts, it is impossible to strategize, innovate, or even just document data practices and their effects, also making it hard to assign responsibility for mistakes, misunderstandings, or willful deceptions in the use of data as evidence for decision making. Essentially, we need to understand data in relation to its context by keeping track of its changes as it moves between people. With that being said, and given that data is flexible and goes through individuals and has their own data journeys, it affects how we as data scientists trust our data and analyze it. Therefore, it's important to understand the data in relation to its context once again. When we originally chose to take on this project, we didn't fully take into account the negative aspects of the Washington Post data, such as it being narrow in its scope, and also it being crowdsourced and possibly not understanding the context of the data. So in turn, we ended up using that data set and took it as ground truth. And we did minimal pre-processing on it and used it to create our visualizations and in turn facts about the data. And that informed our narrative and also informed the narrative we projected to our stakeholders. So technically, under the relational view, our results were quite limited.
So our second dilemma involves investigating ways of reducing the spread of misinformation through data visualizations. So with the rise of big data, we see increased use in data visualizations to communicate findings for a range of issues. The concept of data visualizations is not new, but new technology has made them easier than ever to create. Well-designed graphics can be a powerful tool of persuasion, communicating information that's often not possible through just text alone. But poorly designed graphics can confuse, manipulate, and mislead people. So it's the job of data scientists to make responsible choices when creating these visualizations. It's hard to define the ethical use of visualizations as the rules are not black and white. Deceptive practices, whether intentional or not, can have a big impact on a viewer's understanding. So to analyze this problem, we'll be using the virtue and deontology ethics frameworks. Virtue ethics is pretty broad, saying that we should only perform actions that lead to being a virtuous human, such as being honest. However, there are some exemptions. For example, someone who is honest and spreads rumors or tells other secrets is not virtuous, even though the person's technically telling the truth. And this concept can be applied to data visualizations as well. It's not only important that the data being shown is accurate, but that it's presented in the correct context. Since the moral purpose is to improve understanding, a graphic that is confusing or misleading is unethical regardless of the intent. Design choices such as size, color, angles, and placements can be used to highlight different parts of the information, but should not be used to deceive the user's perception of the story as a whole, which leads us to a deontology perspective. We must consider informed consent. So spreading misinformation through visualizations can limit a person's ability to reason, and therefore doing this is unethical according to deontology. For example, the use of an inverted y-axis in a line graph will probably trick most viewers to believing that the results are opposite of what they actually are, even though the data is technically correct. We must also consider whether a graphic is being used as a means to an end. Violating a person's perception of the data as a means to an end, where the end is to push your own narrative, is also unethical under deontology. So here are some examples of visualizations that we made for our project this summer. In the figure to the left, the total number of police shootings were counted and then grouped by race. While it may appear as if white people are affected more by fatal police shootings compared to any other race, we have to consider this assessment in context. Using the United States population statistics, the proportions of police shootings counted by race were calculated for white people, Black people, and Hispanic people. And the figure to the right, it's fairly easy to see how Black people are disproportionately targeted in police shootings. Once the population sizes of Black and white people in the United States were taken into account, we were able to calculate that Black people are 2.4 times more likely to be fatally shot by the police in the United States. Similarly, we can see the same problem in using the maps of the United States. On the left, we see that California and Texas appear to have the biggest problem when it comes to fatal police shootings if we just look at the total number of deaths. However, when the state's population is taken into account, the states with the most deaths via police shootings are New Mexico and Alaska, and many of the states which appear to have high counts on the left appear lower on this map. So while the graphics on the left, which just use total counts, are not necessarily unethical, it's almost always better to use proportions to portray the correct narrative with data visualizations. The purpose of a good data visualization is to persuade, but there's a difference between using data to persuade and manipulating the data to make a certain point.
When we first approached these two ethical dilemmas, they seem to be consecutive steps on how ethical data science can be practiced. For instance, once we had recommendations on how to solve our first ethical dilemma, we were able to actually move on to the second one. And we quickly realized that both of these sets of recommendations could be adequately described in a high standard code of ethics for data scientists to follow. So for our recommendation for data scientists for both of the ethical dilemmas at hand, we proposed this code of ethics for data scientists, where we have created like an initial framework, especially when it comes to the data collection portion of any sort of data science analysis, and then the modeling and visualization portion. So as you can see, ethical dilemma 1, which is in reference to the relational view, has all of its recommendations also created via that reference, via that relational view. So essentially, what's going to happen is as we go through the different colors, will showcase the different ethical dilemma that we were speaking about. So ethical dilemma 2 is in reference to virtue ethics and deontological view. So first and foremost, we wanted to handle kind of the issue of the data collection itself. So the first thing we added to the code of ethics was one, informed consent. Like, do the subjects of our data set have a clear understanding of what the data is being used for? So this was in response to ethical dilemma 2, making sure that, our kind of code of ethics is in step with the deontological view. And then the second addition was collection bias. So has there been any bias introduced in the data collection method? So this is in reference to the relational view, because it's important to put our data collection methods in context. So we know that through data collection, are we introducing any new bias that we need to account for? Third is missing perspectives. So do we understand the implications of our missing data? For instance, we want a data set to be as representative as possible. So if we're missing a complete demographic from our data set, what is that going to do for our data science analysis? So that also is in reference to the relational view, because it again puts the data in context of the real world. Then we have confounding variables. So are there sources for bias within the features of our data? Not by just our collection methods, but maybe by the actual variables we're collecting. So this was in reference to the virtue ethics and deontological view, because we want to make sure, this just comes down to making sure that we had good visualizations, good models. And so those confounding variables needed to be accounted for so that we had good data. And lastly, for the data collection, it was honest representation. Does our data properly represent the population at hand? We needed to make sure of that. And that again was in reference to the relational view. So these are, 5 steps that we outlined via our ethical dilemmas that we think data scientists should definitely follow when it comes to data collection. And then moving on to kind of like modeling and visualization, we want to ensure, like, after we've cleared the data collection kind of step, how do we go about actually producing good models and good visualizations for our data science analysis? So first, we wanted to keep like fairness across groups. So have we tested the model results for fairness with respect to different affected groups? So as you can see, kind of like in our visualizations, it was important to take into account like the state population. And so that was something that, really provided a greater insight. So fairness across groups was something that we created in reference to like the virtue ethics and deontological view. And then B, explainability. Can we explain like in terms the decisions we made for our model and visualizations? That also leads to transparency, which allows like, any sort of problems to be fixed with our models or visualizations. So that explainability goes back to the relational view, because we want to be as transparent and, really showcase our model and or visualizations in context. And then lastly, we have a point about reassessment and rollback. So like, have we discussed a plan for response if users are harmed by the results of our model? This again goes back to the virtue ethics, right? Because we want to make sure that everyone is being able to, we are producing good analysis. So if anyone is being harmed by our analysis or our model, we want to make sure we can take the appropriate steps to take that model back in and reassess it. So through essentially our kind of analysis on what data scientists should do, we realized very quickly that our 2 ethical dilemmas are fairly rooted in, what we as data scientists kind of need to do moving forward. So for our recommendations for society, these are more concerned about the actual data collection at hand. For instance, as data scientists who use crowdsourced data, it's important that our data is, the best it can be. So some recommendations we had for society is, as a whole, the population should be more willing to contribute to like open source projects or, crowdsourced data, so that we can have like we don't have any missing perspectives in our data set. Then actually having better tactics of data collection for minority groups is a big one, because a lot of times minority groups are not included in data sets just because they can't be reached. And I think that's something that we need to also take into account, so that when we actually have people who go out do data collection, they're aware of this and will put more effort into certain practices. And then we have increased the transparency in kind of data collection methods to reduce like strategically withheld data from official institutions. So this kind of goes back to the data set at hand that we use, which is the Washington Post data set. So there was a lot, it was a lot of different data sources being kind of put into one big data set, but we realized very quickly this needed to be done because a lot of the official sources were actually under-reporting police shootings. So it's important to have that transparency so we know kind of like what data is being held from us and like what that really means in the larger context. And then finally, larger data collection efforts for data diversification as a whole. Like, again, if we are able to get more data, we'll have more perspectives, we'll have more demographics to kind of have analysis of. And I think that's very important when we try to develop good visualizations and good models. So in conclusion, for our 2 ethical dilemmas, we believe that data scientists should follow a high standard code of ethics for any project that they take on, especially for projects that deal with crowdsourced data. And then for our recommendation for society is we would like to, improve the means of data collection, and they should be transparent and open to change anytime we need to really, have a better kind of process of data collection. And thank you.